In the last lesson, we talked about colors. We talked about hues, and we talked about the color wheel. One thing we didn't talk about too much, though, is black and white. Are black and white colors? Well, I'm not actually going to answer that in this video because there's a lot of debate about it, and it really actually depends on who you talk to, meaning a scientist versus an artist. But I do want to go over how black and white work with colors on our screen and on a printed page. Okay, so if we look at our color chart here, we learned last time that a hue is the basic color that we can call blue, we can call red, we can call green, etc. And then as you add dark to it, we call that the shade, and when we add white to it, we call it the tint. Overall, we refer to this as the different value of the color. So the value can be light or the value can be darker. Okay, if we look at a more black and white version of this, you can see how that works, where we go from black to gray to white. Okay, all right, now what we're going to do is we're going to talk about different color modes, okay? And I want you to imagine that you are in a dark room, okay? There are no lights on around you, and you pull out your phone. It's probably already out anyway. But you pull out your phone and you start reading an article, okay? Are you able to read that article in the dark? Yes. Why? Because the light is coming from the source. In other words, it is coming out of your phone from a screen. Okay? Now you put your phone away and you pull out a magazine. Again, there's no light in the room. Can you read that? The answer is no. Okay, if there's absolutely no light in the room, even if you have good, what we call night vision, if there's absolutely no light, you should not really be able to read that. You can't see anything. Okay, and that is because light needs to bounce off of that page back into your eye. Okay, so we have we're talking about two different things here. We're talking about screens versus print. Okay, and so we're going to look at different color modes. Let's start with that screen. The two main color modes that we're going to be talking about, especially when we talk about in Photoshop, is RGB, and the other one is called CMYK, which of course we'll get to in a minute. With the RGB color mode, or color model, we are talking about screen applications. Okay, so this is when light comes from something such as a screen. In fact, we're pretty much talking about screens here. The light is coming directly from the medium. We would be using an RGB color mode, and we call that an additive color model. Okay, we're going to talk about what that means. So RGB stands for red, green, and blue. Okay, RGB, red, green, blue. So if we take these different colors and we start mixing them together, if you let's start with red and blue. Well, in elementary school, we learned that red and blue make purple. Let's see what happens. Well, okay, that's kind of a purple, right? What if we take blue and green? Well, we're going to get somewhere in between there, kind of a bluey green. Okay, yeah, that works. Okay, now what about these two? You may not have learned that, but you know, in mixing paints together, if you mix these two together, you should get sort of a brown color. Okay, well that doesn't really work the way we would expect it, you know. So let's start combining all three of these together and see what happens, okay? So here, remember, we're talking about light coming from the medium, okay, from your screen. So if we take the red and green, put those together, we get yellow, all right? And then if we bring the blue up here, we get a purple. If we bring it over here, we get a light blue. But what happens if we bring this into the middle? whoa, now we have white. Okay, so when we're talking about light, when you're mixing light together, blue, I'm sorry, red, green, and blue, when mixed together in equal quantities, creates white. Okay, I want to show you something here. This is a picture, not a simulation in Photoshop, but this is a picture of three different colored lights, and I want you to see that that is exactly what happened in Photoshop. We have blue, we have green, and we have red mixed in equal intensities, or you know, and when we put them together, we get what we're going to learn in a second is, or in a few minutes, we're going to get magenta, cyan, and yellow, but in the middle we get white. Okay, now if you've ever looked very closely at your TV screen, or your computer screen, or your phone screen, you may have noticed that there are smaller, what we call subpixels. Okay, so for every pixel on your screen, there are three subpixels. They are red, green, and blue. And when you see something white on your screen, you're actually seeing red, green, and blue working together. Okay, and so with these three basic light colors, we're able to see the millions of colors on our screen. Okay, let's take a look at what that might look like. Okay, here is a sample, and this is white lettering. Right, if you look at it, it's white lettering. It looks to our eyes to be white lettering. If we zoom in, however, well, we see red, green, and blue. Okay, so this is what your computer monitor would look like if you put a magnifying glass up to it. Okay, so again, white when looked at far away, but when you magnify it, you see red, green, and blue. Okay, so let's go back to Photoshop here. So we have, again, RGB is red, green, and blue, and that is an additive color model, and, and we use that in screen applications. So anytime that this is that your final project will be on a screen, think of on the web, on a computer screen, on a phone screen, on a TV screen, we're going to be using the RGB color mode. And I would like to say at this point, and I'll probably repeat it again later, that when you're working in Photoshop, even if you're going to print something out at the end, you still want to work in RGB color mode, just because when you go to another color mode, Photoshop kind of closes off some options. So we want to mostly work in RGB almost all the time, and then move to another one later, let's say if we're going to print. So I created a little kind of logo here for RGB, so you can kind of see. Maybe this will help you to remember that when you combine red, green, and blue together in equal intensities, you get white. Okay, all right, so let's move on to the other one. Okay, and I'm going to keep this one up just so that way we can kind of compare the two. All right, let me kind of put these here in the center. Now, let's go ahead and look at the other one. The other one is called CMYK. All right, CMYK. And this is when we are going to print something out, okay? And if you have a printer at home, you may have noticed that there are anywhere from, well, there might only be one cartridge if you have an all-in-one. There might be up to four. There are other ones that include more than four cartridges. Those are specialized printers. Artists or photographers would use a specialized printer to print them out, and they are given more color options. But the basic color printer that you might have at home has a cyan, a magenta, a yellow, and a black color cartridge. Okay, so let's go ahead and look at what those are. This is cyan, this is magenta, and of course yellow. All right. So as we bring these together, well, let's talk about what it means to be subtractive. When the way that I remember this is that when you add the lights together here, you get a brighter color. Okay, so I just kind of think of additive is a positive, and light is a positive thing. Okay, but a CMYK color model is what's known as a subtractive color model. Okay, so that means that when we add them together, this goes for things like paint, or it could go for, in our most of our cases, ink, okay, or toner. So when we add these together, when we add cyan and magenta together, we get blue. Okay, when we add yellow and the cyan together, can you guess what it is? Think about what it could be. Yep, it's green. Okay, and if we add yellow and magenta together, what do you think we might get? Think about this. It's going to be a little bit darker than what you have already, because we are in a subtractive color mode. We have red. So what do you think we will get when we add all three of them together? Okay, if in an additive color mode in RGB we get white, in a CMYK, as a subtractive color model, we get black. Okay, so again, think of this to help you remember. Additive, the word additive is sort of a positive sounding word. You add, and here you subtract. When you add, you get something white, which can have a positive connotation. Subtractive has a negative connotation, and black has a negative connotation as well. Okay, think of that we kind of tend to think of white as bright or positive, and black as, of course, dark and negative. Okay, so but I also want to take a look at, now that we have these two together, next to each other, I should say, take a look at how they kind of correspond to each other. Okay, CMYK creates RGB. Okay, and RGB creates CMY. I just realized I didn't talk about the K. The K stands for key, which really doesn't mean much to you right now, but the key, just remember that the word key refers to black. The way that I remember it is that the word black ends in K. Okay, it's not CMYB. Maybe that is, well, because the word is key, but maybe they did not want to, confuse people with the B in RGB. So, but CMYK stands for cyan, magenta, yellow, and key, also known as black. Okay. Now, speaking of printers, because I mentioned them earlier, the printer cartridges that you might have at home, as I said, are a black, the key, cyan, magenta, and yellow. However, there are some printers that I would consider to be cheaper printers, lesser quality printers, sometimes don't have a black cartridge. In other words, what they do is they rely on this color theory to create black. Now, the problem with that is that it may not really show up here. Okay, it looks pretty good here. Okay, on Photoshop, but really in real life, when you're talking about using a cyan, magenta, and yellow only cartridge, what happens when you mix those colors together, you don't get a pure black, you get sort of a muddy brown. Okay, so in order to get a pure black color, that's why we have the K. That's why we have the key or the black cartridge to enhance those colors. Okay, so that's why we have these 4 colors here. Okay, and I also created a logo for this one, and to hopefully help you kind of remember that, I made the K smaller because it's kind of it's there, but it's also, you know, kind of its own separate color. Okay. Okay, now, so we have these 2 color models, and just take a few minutes to kind of think about some applications when you might see CMYK, when you might see an RGB. Okay, and that's the end of this lesson.